back to quantum mechanics. So what is the psi PR? Psi PR is the R dot P. R dot P. If this picture is also wrong, but we use that to understand. If this is a vector P and this is a vector R, actually, if this is a R and this is a P, by R dot P, we mean the projection of R over or on P. But this is wrong because this vector has an infinite dimension, and this is infinite dimension. But we use our intuition from the geometry, no? R dot V is the projection of the R over the B. Remember R dot V. A and B. What is that? This is a projection of the A over B. And it is related to A dot V. This is completely wrong, but we use that just to understand, because they are the element of the Hilbert space, so this kind of the writing is not so correct, but anyway. If you give me P, I can calculate that for you. So I will use this, so minus IH bar gradiane P will be P. What I will do is that I multiply this to the vector R from the left side. If you multiply to the vector R from left side, that will be acted on that, will be minus gradiane R dot P, P R dot P. And this equation is like minus IH bar partial derivative of the x, for example, equal to something. So the solution of that, you know what is the solution of this? Exponential. This is the solution of this. If you're not sure, just take the gradient from that, you will see it. Still we have a problem because there is a normalization here, you don't know what is the n. For normalization, you needed to use this condition. I don't go the inside of that, but n will be 2p h bar over 3 over 2, just by normalization. So this is psi PR, huh? This is what you are looking. So to find the normalization, what you needed is to do that. You needed to calculate for me psi PR, psi star, P prime R, D cubic R. If you calculate that, you will see that according to the normalization, it should be this, because they are orthogonal, these wave functions. And if you calculate it, this side you will get, because they are exponential, just put it here, and you will get n squared 2p h bar power 3 delta p minus p prime. And here, in this side, you have a p minus p prime. So from here, you can find the n. Just a step. I can do that, but it's not very important for us. The important thing is that we have the RP, or psi PR. You can do that at home. Maybe I will add this to your last assignment for the home. So I have psi PR, so let me to complete these calculations here. So not so hard now. I will tell you how to do that. So this is a psi PR. So I needed this. I don't remember that, but I will. So what is needed is now we needed integral of d cubic p psi PR 1 over 2p h bar 3 over 2 e I p dot r h bar e minus beta p square over 2m 1 over 2p h bar 3 over 2 e minus I p dot r prime over h bar. Yeah. So this is very easy actually. Look at that, what I can write is very tricky. I write this, the cubic of the another integral like that, you will see. If you make cubic this integral, so it will be px squared, py squared, pz squared. It will give you to this. And if you make it this cubic, it will be px minus px prime, py minus p prime, pz minus p prime. It's exactly p minus p prime, p minus the other. Sorry, it's px x minus x prime. Yes, sorry. If you're not sure about how to make it this, another strategy is that this. Take an r minus r prime here, like the vector z, and this is your vector p, so this angle is theta. Take p dot r minus r prime, what is happening here, what is appear here, as a p r minus r prime cosinus theta. This is another method. And of course, p squared is p squared. And instead of the d cubic p, write just normal, remember normal spherical coordinate. 2p p squared dp sinus theta d theta. And make the integral. Either this or either. But I prefer that because it's more easier. One-dimensional integral is very easy for me, instead of doing the calculation in 3 dimensions. So let me to see the structure of this integral. This integral which I want to calculate is like this. Yes? Just if you make it a and b, like the coefficient of p squared and the p. What's this integral? So the value of this integral is p over a e b squared over 4a. 2a or 4a. Let me add a. If you don't know how to find that, we need to find it. We need to find this integral to be sure. Okay? So I want to prove this integral because I'm not sure about this 4 or 2. I can check it from the book, but I don't want to do that. Let me to see that how to evaluate this integral. The way is that just make a factor from a. Okay. Okay. And make it this complete. So the integral will be minus a multiplied to this will be e b squared over 4a, integral of this. Okay. What is this integral? If you change p to p minus b minus 2, this limit doesn't change because it goes from minus infinity to infinity. So I can take it this anything you like. Why? Huh? What is the integral of minus infinity to infinity? This is the radical p over a. This is the integral which you know from the holiday, chapter 21, holiday. But that was the correct one. So, sorry, this is a. So what I wrote it was previously b squared over 4a radical p. So I used this. This is a Poisson integral actually. I used this Poisson integral, and I want to complete the form for the row. If I do the Poisson integrals, will be cubic. Let me to see what it will be. Radical 2ph bar exponential b squared. What is the b? B here is I x minus x prime over h bar. B squared. 4a. What is the a? Beta over 2m. Yeah? I wanted to simplify that, so minus x prime squared. Look at that, what I will do is 2 by 2 cancel. M will be seated here. 2 beta h bar squared. Yeah? Cube. If nothing wrong here, because I think it's okay. Yeah. Oh, there is a one radical PA also, huh? Radical PA also. Sorry, I see that something is wrong here. Multiply to radical P over A. What is the A? A was beta over 2m. Beta radical 2m. So will be radical 2mp over beta. Okay. So you can make it this simplified. Now radical 2p by radical 2p you can call simplify. You can write m beta h bar exponential. How many power? Power 3. Exponential. Look at that. To make this power 3, again I back it. So this is a x minus x prime. If you make power 3, it will be plus y minus y prime plus z minus z prime. So I can write this r minus I prime square. You never can understand this if you don't do this by hand. You needed to do this calculation one time for yourself. More than one time, so after that you will, because I did that in the past, so I did it one time actually in the past. But this is the form of the matrix, and very strange type of the form of the matrix. M over beta h bar. I want to check it with the book because I want to see that. So this is the matrix arrow, but you needed to check again the coefficient or something. Maybe there is some coefficient different here. Radical PA. My dot is also only here, but when you multiply this, radical PA. So one was radical here, that's okay. Radical TA, radical 2mp over beta. Where is radical 2mp over beta? 2mp over beta, and there is a one radical 2p here. So they multiply to each other, m remain here, that's okay. This is okay. And this is okay. I think it's okay. So this is the matrix. And at each r and r prime, this is the element of your matrix. Very strange. The row and the column are here running from minus infinity to plus infinity. Yeah? This is a continuous system actually. It seems that is finished, but you needed to do one thing. we needed to do one thing. The thing is that we need to find the trace of this rho. Huh? We needed also the trace. But the trace will be hard. Not hard, actually. But I told you, please check it again, this, because I write it. I didn't check it the book. Maybe there is a 2 or something here, but I don't see any difference here. Anyway, but check it one time more, all the steps. So to find a trace, so trace this rho matrix is sigma rho RR, no? Something like that. We don't have this, we have a, we have that. You needed to set R equal to R prime. When you set R equal to R prime, this exponential will be 0. Exponential of 0 is 1. So it remains just this factor. What is that cubic exponential? What is the this? This is the volume of the system. Okay, so this is the trace. So you can now write for me the matrix rho and the rho prime is exponential. The matrix I write it, so I don't need it to write again. I've already write it. So this question was a little bit difficult. So the next one is more hard than that. So it's harmonic oscillator. So there is no any reason actually to solve the harmonic oscillator again, because we solved harmonic oscillator before by the canonical method. When you have the energy level, we just calculated exponential minus beta En. And also we can studied that in the first chapter using the microcanonical. And you can start it by that. I just started, but I'm not sure I want to complete that, because we know what will be expected. We already know from the last chapters, former chapters, the form of the partition function and many things for the harmonic oscillator. So there is no benefit to do that by the fundamental. Anyway, simple harmonic oscillator is a system which the Hamiltonian for the system is given by the P square over 2m plus 1 m omega x square. But the difference here is that the system is quantum mechanical. So you know that this operator x and the p are satisfied with these relations. And the thing is that if you solve the Schrödinger equations, to solve the Schrödinger equation, you needed to define a format. We call it Kesey, just format. The psi n Kesey will be radical n factor exponential minus Kesey square Hermite Kesey. This is a called Hermite function. Is one of the transcendental functions, Hegel or special function of the mathematical physics, Hermite functions. This is the form of the normalization for the wave function of the harmonic oscillator. So this is very difficult to work with this function, so I never do the calculation for harmonic oscillator by this Hermite. The strategy is that we define a set of the unit vector for the harmonic oscillator, we call it this by n, Of course, if you multiply Kc to n, you get this psi n Kc. But I want to work with this keta n. So what is the benefit? The benefit is that if you have a Hamiltonian, over n, so this is, I know what it will be, h bar omega n plus 1 over 2 n. N is started from 0 to 2. Because this is like psi n, so h over psi n is E n, and this is the E n, this is the energy. So let me to write the matrix. The matrix which I want to write, again I want to write in you can write in the different representation, in the representation of the P, X or something else. I want to write it this.